Hi, everyone. Thanks for watching my webinar. My name is Charles Chung, and I'm with A.M. Fitzgerald and Associates. Today, I'll be talking about levels of MEMS solutions, advantages, and applications. The entire webinar will be about 20 minutes. A.M. Fitzgerald, we're a MEMS product development company. We have three classes of engineering services. The first is MEMS innovation, which is where we create and design new MEMS devices. Often intellectual property is created here. The second is MEMS solutions, where we help our clients find manufacturing solutions to get to market. And the third is technology strategy, where we help our clients do studies on their MEMS product development. For example, we may do a study on competitive analysis of the market or a landscaping of the intellectual property. You can find a lot of information about us at our website at www.amfitzgerald.com. So what I'll be talking about today is, first of all, I'll start out with MEMS and why add them to products. I'll also talk about the 4 levels of MEMS solutions of product development, give a description of each one, talk about the advantages and applications of each. Third, a little bit about A.M. Fitzgerald's MEMS solutions, and finally, a summary. I should say that this webinar is targeted for folks who are more the users of MEMS rather than developers of MEMS, but I hope everyone finds it useful and interesting. So you can think of MEMS as a powerful miniaturization technology. MEMS is an acronym that stands for Micro Electromechanical Systems. It's very closely related to microchip semiconductor devices. In fact, it's a branch of that. Except for that, we add non-electronic components onto the chip. So a good example of MEMS miniaturization is the navigation unit. This is a navigation unit from 1995. It's a cube about 6 inches on a side, and it can detect whether you're moving forwards or backwards, or turning left or right, or moving up and down. 20 years later now, this cube has now been shrunk into a microchip of this size, and the innards of it have components that are smaller than a human hair. So what can you do with this kind of technology? Well, these days you find MEMS chips in every smartphone. There are at least 5 in every smartphone. That navigation chip that I just showed you is in smartphones to help detect whether the phone is pointing up or down. It can also help navigation while using, for example, a maps application. Automobiles are a particularly rich environment for MEMS chips. There are at least 100 MEMS devices in every car, including accelerometers to detect collisions to deploy airbags, as well as pressure sensors and flow sensors to monitor engine performance, and pressure sensors in the tires to monitor tire pressure. And today now we're finding MEMS devices are being found in the human body. These are examples of the cardio MEMS pressure sensor. They're located in the aorta and the pulmonary artery, and they are able to detect pressure and then wirelessly communicate that data out to a clinician. And so there are lots and lots of different MEMS devices. They include inkjet nozzles. These are the tiny micro pumps that are used in every inkjet printer. I talked about a little bit of accelerometers and gyroscopes. Those are the navigation devices. The phone, I said, had 5 MEMS devices. One is an accelerometer, one is a gyroscope, 2 microphones, one for voice pickup, one for noise cancellation, and a magnetometer, which is used for the compass. And more devices are coming on your smartphone. We're starting to see pressure sensors used as altimeters. We're seeing environmental sensors, which are not listed here, but chemical sensors to detect levels of, for example, humidity or particulate matter. And we have a whole host of other kinds of micro electromechanical chips. So suppose you'd like to get one of these chips into your product, what would you do? So there are lots of ways to think about this, but one way to think about it is there are 4 levels, so to speak, of MEMS solutions, and those are the system level, the package level, and then 2 chip level solutions. One is semi-custom and one is custom. So let's start off with the easiest one. This list is generally goes from the easiest and the least expensive and the least risky solution to the most expensive and the most risky solution. But often, this is where the greatest rewards are as well. So let's start with system level solutions. System level solutions require these components. You need to have some off-the-shelf packaged MEMS chips. We'll talk a little bit about the difference between a packaged and an unpackaged chip. You start off with off-the-shelf electronics typically and a PC board. And what you need to do in order to create a solution is essentially provide the glue and the interface for all these components. So the glue would be mechanically attaching these chips to the PC board, electrically connecting the chips together, and then the interface would be including mechanically incorporating this board into your product, also providing the software interface so that users can use this product, as well as the data analysis in the case that any data is generated. The advantages of a system level solution, as I said before, is this is often the quickest and cheapest solution. Let me give you an example of that. This is a TPMS, that stands for Tire Pressure Monitoring System. This example is from Schrader. Schrader provides TPMS systems to Nissan, Toyota, Jeep, and other car manufacturers. So on this image shows you a system level MEMS solution, and on this is a MEMS sensor. This is used to measure tire pressure, so there's a pressure sensor here. That pressure sensor sends a signal to the ASIC. You can think of the ASIC stands for Application Specific Integrated Circuit, and you can think of it as essentially the microprocessor or the brains of the system. So the pressure sensor detects the pressure, sends it to the microprocessor. The microprocessor then sends the signal to the RF or radio frequency section, which then communicates to the car through the antenna using the same frequency as your wireless key fob uses to unlock your car. And you can see some of these components on the board. This component is a pressure sensor. This is a packaged pressure sensor. This is a packaged ASIC. And all these components are integrated and put together at the system level by connecting them on this board. There are a couple of other components on here. This device is a transponder here. This is used as another way to communicate with the system, usually used by the factory. There is also a battery on here that is not shown. And then there's a motion sensor up on the opposite side of this board. And the reason why you want a motion sensor on here is that this system is designed to work off a small battery for 10 years. What the motion sensor provides is, in order to conserve energy, you only need for the system to be turned on when the car is in use. And so what the motion sensor does is it detects when the car is moving. When it's moving, the ASIC wakes up. It then takes pressure readings once a minute and then communicates those readings to the car. So that was a system level solution. Now let's talk about package level solution. Now, whereas a system level solution started with packaged MEMS chips, a package level solution starts with unpackaged MEMS chips. So let me talk about a little bit about what packaging is. These are unpackaged pressure sensors, MEMS pressure sensors, and you can see this little round thing is the diaphragm for the pressure sensor. It deflects under pressure, and then that deflection is transduced into an electrical signal. From the back, you can see that most of the silicon has been etched away, and all you're left with is this thin membrane down here. Now, these bare silicon pressure sensors, they are small, and so they tend to be hard to make an electrical connection to. And they're vulnerable to the environment. Water will corrode this, as scratches will damage the chips. Dropping the chip or mishandling the chip can cause the chip to chip. And so these little silicon chips need protection, and that's where the that's where the packaging comes in. So these are examples of packaged MEMS devices. They're protected by encasing them in some material, sometimes plastic. These accelerometers are encased in plastic. Sometimes metal. These infrared cameras are encased in a metal can. Sometimes a ceramic. I don't think we have an example here. So the packages provide protection for the chips. They also provide electrical connection for the chips. And you can see these leads here, for example, on these pressure sensors make it easy to make an electrical connection to. These pads on the back of these gyroscopes make it easy to solder a trace to this gyroscope. So a MEMS package level solution will start with an unpackaged bare silicon die, and then you will essentially package it, which involves mechanically attaching the chip to the package, providing the electrical connections, providing the environmental protection. And so what you'll need to do in order to get to a solution is you need to do all this plus the system level integration. And so why would you want to do this? Well, there are a couple of reasons. One is that you can add a lot of value with specialty packaging. A good example of this is the St. Jude Medical's pressure wire. St. Jude is a large biomedical device company. They have particular expertise with catheters, and what they've done is they've placed a pressure sensor on a catheter. Now, the reason why you want to do that is this pressure sensor goes through the cardiovascular system and it detects pressure, and it would read a normal pressure here. And then as it passes through a blockage or a stenosis in the cardiovascular system, the pressure will drop. And the amount of pressure drop characterizes how much blockage is being, how much of the artery is being blocked by this stenosis. And so the width of this catheter is probably on the order of 1/3 of a millimeter wide. The pressure sensor must be even smaller, so it's about 1/4 of a millimeter wide. And this is a case where St. Jude does not want a system level solution. What they want is they want a package level solution, because St. Jude has a lot of expertise with catheters, and they can increase the value of both their catheter as well as the MEMS side by combining them together in essentially a specialty packaging. Another reason why you might want to do package level solutions is that it's cheaper in larger volumes to do a package level solution, and also higher reliability. So let me give you an example of that. Previously, I showed you that navigation, that big 6-inch cube that's been shrunk down into a chip. Well, this is the inside of that chip. From the cross section, you can see there are 4 chips inside of here. There's an accelerometer, a gyroscope, and then an ASIC or microprocessor for the accelerometer, and an ASIC for the gyro as well. And these 4 chips are all housed together in a single package and then wrapped. You can see these little electrical wires provide electrical connection, and then it's all encased in plastic. Now, the reason why you might want to do this, if you look at a system versus package level solution, we can go back to that Schrader system level MEMS solution. And this is a system level solution. This is a package level solution. So you can see this is the Freescale TPMS system. On the front, we have a pressure sensor. And on the back, we have the accelerometer, a microcontroller, and then the radio frequency transceiver. And if you look at the board level, you can see that on this board, there are only a few components. This package here is this package. It has 4 chips in it. And then there are a few other components on here. And in this case, you can see the battery. But you can see that this board is cleaner than this board. This board has more components. All these little components here are capacitors and resistors. This board is also populated on the back, and altogether there are probably 30 to 50 components on the board. On this board, there's probably something like 10 or 15 parts. And so there's a lower part count, there's less assembly, and so there's a lower per unit cost, and the system tends to have a higher reliability because there are fewer mechanical and electrical connections that fail. So that might be a reason why you want to go with a package level solution. So we talked about system level solutions, we talked about package level solutions. Let me now turn to chip level solutions. Chip level solutions there are 2 types, there's semi-custom and custom. And if you would like to do a chip level solution, you need to essentially have expertise in chip design and manufacturing, as well as then provide the chip packaging and the system integration to come up with an entire solution. So why would you want to do this? You can see this is more involved. The reason why you might want to do this is, first of all, this is probably going to provide the most sophisticated functionality in the smallest amount of space, and this can create new functionalities and therefore competitive advantages. So let me start with a semi-custom solution. What do I mean by semi-custom? Well, what I mean is that it's a situation where you need some customization, but you don't need an entirely new type of chip. So what you might need to change are things like the chip size or shape. You might need to move the bond pads around. Electrically, you might want to change the chip's impedance or voltage values. And you can use a semi-custom, or you can pursue a semi-custom solution if you have an established MEMS chip. So pressure sensors, accelerometers, gyroscopes, digital mirrors, these all have established MEMS manufacturing processes that are potentially available to you. So if, for example, let me just make a point here. The reason why you want to pursue semi-custom over a custom chip is that semi-custom is an order of magnitude cheaper, faster, and lower risk than custom chip development. And when I say an order of magnitude, I really mean an order of magnitude. When it's cheaper, I mean a semi-custom approach is hundreds of thousands of dollars versus millions of dollars for a custom development. When I say faster, it's months of development rather than years of development. So let me give an example of some of the semi-custom pressure sensors and accelerometers and gyroscopes. This is an example of the Rocket MEMS, our Rocket MEMS pressure sensor program. And in our program, we can, for example, take a pressure sensor process, and then we can customize the die width and length, so we can change the size and the shape for the die for you. We can move around the pads. We can also electrically adjust the resistance bridge. We can also adjust, for example, the offset voltages. And by combining all these parameters, we can customize the pressure range and the pressure sensitivity for your sensor. There are a number of foundries in the world that also offer manufacturing processes that are available to the public for accelerometers and for gyroscopes. DALSA, XFAB, and Tronix are 3 foundries that have these platforms. And if you would like to pursue a semi-custom motion sensor, these 3 entities are pure play foundries, meaning they only do the manufacturing. If you'd like to approach them, you need to have a design, which means that you need a MEMS designer. And if you don't have a designer, we would be happy to help you with that. Finally, you have custom level chip solutions or custom chip level solutions. And this is the most involved solution, but there are a number of compelling reasons why you might want to pursue a custom MEMS chip. The most may be that you would like to create a new major competitive advantage for your product. And this is often a situation where there's a new MEMS technology with some strong patent opportunities. But those aren't the only reasons why you might want to pursue a custom chip. You might also have a situation where you have an existing chip like a pressure sensor or accelerometer, but you have unusual sensor specifications. Like you might need a device that's unusually high performance. Aerospace needs unusually high performance navigation chips. You may have, for example, a pressure sensor that needs to operate in an extreme environment. The oil and gas exploration industries, for example, need pressure sensors that can work at thousands of atmospheres and hundreds of degrees C. And so most pressure sensors will not work in those sorts of environments. So you may need a custom chip for that situation. Or you have some odd geometries. For example, in medical, you often find a need for chips in odd shapes. That catheter I discussed earlier has a need for a chip that's long and thin, which is, most chips are kind of squarish. So that's unusual sensor specification might be one reason. Another reason why you pursue a custom chip. Another reason is that you might want a custom chip just to control the supply chain. We've had clients who have some strict regulatory requirements, and so they need to make sure the quality on their supply chain is high. The way they do that is they control the supply chain, and so they would like to have their own MEMS chip, which means they have their own MEMS design, their own MEMS manufacturing process. And by doing so, they also have their own MEMS packaging services as well as system integration. And by controlling this entire chain, they can meet their regulatory requirements. And this, by the way, also creates a significant barrier to competition. A custom chip is a long investment, an expensive investment. It takes 2 or 3 years of development and at least $1 million to get to market. These are sort of minimum times. It depends strongly on the sort of technological ambition of your chip. So here are some examples of some custom chips that we have worked on. This is part of a micropump that we worked on. This is an infrared imaging array. This is the tip of a needle with a sensor built into it. These are micro lenses. This cantilever is part of a chemical sensor. This round-shaped thing down here is a rotary positioner for to make sure your micromirror is pointed in the exact right direction. So regardless of whether you're pursuing a system or package or chip level solution, for us the process is largely the same. We start with an idea. The client usually comes with an idea, and the first thing we do is we're big believers in strategy. Or doing our homework, and that means usually a strategy study. And what we would do in this case is we'd look at your idea, look at what product you're trying to develop, and we may do a strategy study, for example, looking at the competitive competition to make sure that your device has some sort of advantage in the marketplace. Or we might do an intellectual property and an IP study to make sure that once you get to the market, that you have freedom to operate in that market. Once this homework is done, we then go into a design stage. We can, for example, design a device then that has an advantage in the market or has freedom to operate. We would also design the manufacturing process at the same time. They kind of go hand in hand. And then we would go and finally start prototyping your device. Um, uh, and after that, we would then help you find a manufacturing solution. For a system, it would be an assembly house. For a package, it would be a packaging house. For a chip, it would be a semiconductor factory. We've done this process now with 140 clients over 13 years, and so we have some deep experience here. So in summary, MEMS is a powerful miniaturization technology that can add some pretty sophisticated functionality to your product. You can integrate this technology into your product at several different levels: the system level, the package level, and at 2 chip levels. And finally, A.M. Fitzgerald is a world leader in MEMS product development. We're pretty good at this, and we'd be happy to work with you to find a solution that works best for your product. If you'd like more information, or if you have any questions, you're welcome to contact me here at ccc@amfitzgerald.com. You can also find a lot more information on our website. There's a page for our publications, and we have quite a few published papers on MEMS technology in general. So with that, thank you very much for your time and attention, and please feel free to ask me if you have any questions. Thank you.